Okay, let's get started. Good morning. Welcome to how to write Python code that others like to use. Today we're going to talk about Python API design and how do you, when we're shipping SDKs or libraries or modules, how to design an API that other people like to use. My name is Anna. I have worked at Microsoft for the last 5 years, based out of Seattle. And I write Python SDKs for the Azure cloud services. That is my GitHub handle there. It's just my name, super easy to find. I will publish these slides to a repo on GitHub after this presentation. So if I do go through a little bit fast, don't worry about needing to write everything down. And because I will be going through quite quickly, I will ask that you please hold all your questions till the end. So, one of the key motivations behind this talk, and one thing that we observed a lot in the SDKs that we were publishing at Microsoft, is that libraries were being written in isolation. They weren't nice to use together. And when you're publishing a library in Python, whoever is using it is not going to use your library exclusively. It will be part of a chain, a pipeline of many different libraries that work together. So when we're publishing code, perhaps it's an open source library, or perhaps you're simply distributing code within your organization, within your team, some utility scripts. We need to make sure that that Python code works well with other libraries. How do we achieve this? Well, with Pythonic API design. We can't force users to write Pythonic code. However, we're doing them a disservice if we don't allow them to write Pythonic code. We shouldn't prevent them from being able to write clean and efficient code. So when we design an API, we need to look at what feels natural. There are certain patterns that are instinctive to Python developers that they will intuitively start to use as they gain experience. So we want to be able to utilize those natural patterns. We want to leverage concepts that are familiar. There are a number of libraries that have become industry standard, whether they're third-party libraries or they're modules that ship with Python. We want to be able to leverage what's recognizable so that we can reduce the learning curve to new users. We also want to make sure that our SDK designs are intuitive. If we are introducing new or complex concepts, we don't want to make it hard to understand. We want people to be able to intuit their way around an API instinctively. So here are some of the things we're going to cover today. First, if we already have an SDK or a library, how can we verify that API to know whether it's Pythonic or not? So a couple of steps that we've been using within our organization. Step one, to compare that library to other libraries. As I mentioned, there are a couple of libraries that are now industry standard. They've already done the hard work. How can we leverage that in our own designs? Step two, user studies. And this, again, is something we've been adopting a lot internally at Microsoft to actually test our assumptions that we made when we designed this API. Now, after we've done this verification, we put together a set of API guidelines that we apply to our SDKs that we're shipping going forwards. If anybody here has any experience with the Microsoft SDKs for Azure, you'll know we have a pretty patchy history in this regard. So I'm hoping that what I'm sharing in terms of guidelines today will help you learn from our mistakes going forward. Some of the things we'll cover, context managers, symmetry in APIs, and reusing inputs and outputs, objects versus dictionaries, iterables, minimizing our API and our method signatures, naming, object model hierarchies, and if we have some time, I'm not sure at the end, async APIs. We'll also touch on documentation, and then we'll summarize it at the end. Okay, so throughout the talk, I'm going to work with a sample client. We're going to assume, imagine we have a REST API that is a queue service. We can create a new queue, we can submit messages to the queue, we can receive messages from the queue. So we have our queue client. We can instantiate it with an endpoint, some auth, and some HTTP configuration. We can create a queue by giving it a name and some various other HTTP parameters there. We can add a message to the queue, get a message from the queue, clear messages from the queue, close our connection to the queue, delete it, And then we also have a class for the message that we receive when we get a message from the queue. Currently, this is the code that a user would have to write if they were consuming our API. They import our module, instantiate our client, create the queue. We're, over a range of 5, adding 5 messages to the queue. While true, we're going to empty all the messages from the queue by receiving them, testing that we did in fact get a message, and if not, break out of the loop. Otherwise, we're going to print the ID and the content of that message, process it in some way, clear the message from the queue. We are specifying some timeout values in our HTTP configuration, so we'll make sure that we handle those errors if need be. And we have a finally clause to close the connection afterwards. So far, so good. Straightforward API, relatively easy to use. So step 1 in verification, how does this compare to other libraries? Do not be reluctant to copy the API of another library. This helps to accumulate familiarity and it reduces the learning curve for new users to your library. How do you tell if a library's API is successful and whether or not to copy it? How widely has it been adopted? Does everybody know this library? Does everybody use it? How did you find it? Take a look at their issue tracking. How many issues have been filed that are relating to misunderstanding or questions? And if a lot, then perhaps that API is not necessarily so intuitive. Take a look at their documentation. If they require huge amounts of paragraphs of text to describe all the nuances in their API, once again, perhaps that's not so intuitive. So we're going to do a super quick sample here. Imagine we want to write a client library for downloading a file. Super easy. We create a class, it's a file client. We can instantiate it with an endpoint, a token for authentication, one function, download. Takes a path and a file name. So what does the user's code look like? Import the file client, instantiate the file client with the endpoint, give it an authentication token, file client.download, directory name, file name, done. 3 lines of code, super easy. However, what is the most common scenario for downloading a file? You're given a file URL. We do this every day. So, given this URL, how can a user use our client to download a file? Well, now we have to import some URL parsing, parse the URL, construct the endpoint, parse the query parameters. We pass in the token query parameter and some configuration parameter. We have to separate the path to get the directory name and the file name. And then we can download our data. So look at all this code that we've forced our users to write. And now the user also has to write a lot of test cases to get all the edge cases for that scenario. How did requests do it? Given our URL, import requests, requests.get. So how can we leverage this super simple API and the familiarity that comes with such a ubiquitous library as requests? Well, why don't we do the same thing? Import foo.download file. So what does this code look like now that we have to write this into our SDK? Well, we still have our file client. But now we have a module level function called download file. And what does this function do? Exactly the same code that we were previously requesting that our users write. But now we've taken that burden, we write the tests, and we've given our users a simple and easy to use experience. And we've taken away the complexity of using that file client. So let's take a look at our queue service client that we talked about before. Turns out Python already has a queue class, so there is already an API available that users of Python are familiar with, so let's adopt that. And rather than add message and get message, they just have a put and a get and a task done. So let's update our queue client. Now we have put and get and task done. Update our user code to replace those function names. Step 2, user studies. Now this can be a hugely humbling process as it challenges all the assumptions we made when we designed our API, but I highly recommend you do it. When you're observing a user, if possible, ask somebody to try out your code who has no familiarity with how the code was written. Oops, let's go back. But ideally, they have some Python experience, and up to you whether or not they have experience with the features that your API is presenting. Key point here, user studies are not going to tell you how to write an API. They're not going to give you the answers. Ideally, they will tell you where to start asking questions. Look for where users stumble and why. Ideally, ask them to speak aloud. Often, they'll tell you where they've made an assumption, and then that has chased them down a rabbit hole that they're unable to get out of, and they hit a dead end. Or you can ask them to work in pairs. Having two programmers explain their thoughts to each other is a really great observational tool. When do they seek guidance? And when they do seek guidance, where do they seek it from? Do they look for a README in your repo? Do they look into the actual code itself? Do they look for documentation? And if so, how do they find documentation? And what form of documentation do they end up using? Do they read your reference API documentation? Or do they look for code snippets that they can copy and paste into their own work? And spoiler alert, it's code snippets. So we've conducted a lot of these user studies now, and we've come up with these API guidelines that we distribute internally to teams building Python SDKs. These are what worked for our users based on our user studies. I highly recommend you go through this user study process and come up with your own guidelines. However, I'm hoping you can also leverage some of what we've come up with here. So, starting with context managers. If you have any chunk of code that ends with some finalizing statement, it doesn't have to be a closed connection. Anything that needs to, some form of follow-up behavior, anything that needs to be closed, shut down, discarded, or deconfigured, this should have a context manager. It is a very Pythonic pattern that users of your code will want to use, and it stops them writing more error-prone code. However, we should always give users the option to flatten a context manager. They may not want to use a with statement, in which case we should allow them to explicitly close or discard or shut down whatever it is that you're doing. So now we have our QClient example, and you can see here we've added two dunder methods to the top there, an enter and an exit. Enter simply returns the instance. Exit is simply calling our already publicly available close method. So this client can still be flattened out, or it can be run within a context manager. We've updated our user code here, and now we have a with statement with our QClient, and we've dropped the finally statement at the end to clean up the user's code a little bit. Symmetry. I'm going to combine these next 2 points together because they actually relate to each other. So there's two types of symmetry we can look for in an API design. The first is symmetry between pairs of operations. Often operations will come in a set of pairs, for example, upload and download, create and delete, get and set, get and put. So these are operations that should mirror each other, and their method signatures should reflect that. So consistent naming in the method signature, consistent parameter names, consistent order of parameters, and consistent configuration options. If you start to change things, it will give a developer pause. They'll wonder why it's different. They'll wonder if there's some nuance that changes the behavior of this method. And then they're forced to consult your documentation. Another form of symmetry is between inputs and outputs. A lot of operations will be chained together. A user shouldn't have to take the output of one function and then manipulate it and pull it apart in order to pass it into the next one. So what comes out of one function should be able to be passed directly into a subsequent operation. So how can we apply this guideline to our client? Well, we have there a create and a delete method. So there's a pair that we can currently look a little bit inconsistent, so we can fix that up. We also have three methods here, put, get, and task done. Get will give us a message object, but put and task done take a content and a message ID. So we can facilitate passing around the output directly into the inputs. So now our functions might look a little bit more like this. We take a message as a parameter. We check if that message is a complex object and pull out the attribute data if we need it. Otherwise, we pass it through directly. How does our customer code look now? Not a whole lot different. You can see we've changed the create function name. We've also changed the task done method, so now that it takes the message directly. Objects versus dictionaries. Okay, so if you come from a different object-oriented language, it may be an instinct or a compulsion to represent everything as objects. Our user studies say don't do this. Python developers prefer to use dictionaries. They will naturally look for dictionaries. So when in doubt, just use a dictionary. They make use of convenient features in the language like dictionary comprehensions. They're familiar and they can be passed around between different libraries that you happen to be integrating with. From a performance standpoint, they're more efficient than objects. They are printable. Python developers often come from a background of developing in a text editor. They're not necessarily comfortable with debuggers or the various features of a full IDE development environment. Therefore, the print statement is still a very common debugging tool, and we should make sure we can facilitate that. And they're very flexible. However, objects have some of their own advantages. They're easier to document, provide a better IDE experience. They can follow explicit rules, and we can implement various code under the covers for verifying different inputs. They don't require any string manipulation or passing around dictionary keys. How about both? So we can use an object, and then we can give it a dictionary-like API. We get most of the benefits of a dictionary, but we get to pick and choose which features we want to keep. We can either implement this as a series of dunder methods directly onto our model, or we can create a reusable mixin if we have multiple models that we want to give this treatment to. So here's an example of a dictionary mixin. So here we have a number of dunder methods. I'm not going to go into what all of them do. You can find code like this on Stack Overflow, and that will give you details on how to use each of these individual dunder methods, as well as the Python documentation. But this gives us some benefits. It means that we can now use dictionary comprehensions on our complex objects to filter data. We can extract the data or the attribute names with the keys and the values operations. And we can also use the get, a dictionary.get, to set default data. So now we have our updated message class, which now inherits from our dictionary mixin. We set our ID and our content, and we'll give it a custom string representation as well, so that we can print this out with the ID and the content. How does this change our user code? Again, not a huge change here. However, now we can print the message directly, and we know what string that's going to output. We can also, when we get the content from the message, we can do this as a dictionary get operation and set a default value if we need to. Iterables. Common misconception that iterables just deal with lists. This is not true. Any operation where we're forcing users to write a loop to go over our code, this has the potential to be redesigned as an iterable operation. Some examples of this are consuming data, for example, a string, producing data, for example, with generators, and paging through results, such as search results or query results. So let's take a look at our user code again. And you'll see here we have this giant while true loop in the middle, just to clear the messages out of the queue. So this looks like a good candidate for creating an iterable interface. So we have our queue client. We have our get operation to get a type message response. Let's create a new operation called iter. And this is going to return a different object, which is a message iterator. Now, to define our message iterator, we take an instance of the client, our queue client, along with the queue name. And we want to implement two dunder methods here. The first is iter to define this as an iterable object, which just returns its own instance. And the next is the dunder next operation, which determines how to receive the next message in the queue. In this case, we're just calling our get function. We want to raise stop iteration if we run out of messages. This error is not raised to the user. It simply signals to Python that the iterator is complete. OK, so now we've updated our user code again. So now we have this for loop in the middle, for message in iterate my queue. and then we can process those messages. So already we can see that our code is getting more succinct, more readable, and more Pythonic. Minimization. So we want to reduce the complexity in our APIs. If you have a very complicated operation, it may take a lot of configuration parameters. It may be tempting to put all of these parameters into a complex object and pass it in. In our user studies, Python developers prefer to specify these complex configuration as keyword arguments. This makes for cleaner, more readable code. However, just because you've specified keyword arguments in your method signature does not force users to use keyword arguments. A keyword argument can still be passed in positionally. So we want to encourage users to use keywords wherever possible. If you're using Python 3 only code, there is a dedicated syntax for this with a star. Please use it. Otherwise, you want to roll up your less common configuration options into ** kw args. Removing all of these optional settings from your method signatures reduces the complexity and allows the user to focus on what they need to know now upfront to get things going. And then your documentation can guide them into the complexity of configuring and tweaking all the little settings that you might have. This also helps to make your method signatures less breaking if you want to reorder parameters or rename parameters. That will result in less breaking changes for your customers. So now our API is looking a little bit cleaner. We've taken all our HTTP configuration arguments and squashed them into KW args. This does mean a little bit more work for us. Now for all of our functions, we have to actually process those KW args, and yeah, we'll add a little bit more code to our client. From a user's perspective though now, we have forced the user to specify the keywords for their timeout values and their logging value. This makes their code more readable and makes their code more maintainable. The other minimization we look for is patterns. So if we're forcing users to write loops, if we're forcing users to repeat themselves, then that's potential that we can make our APIs more convenient to use. But we don't want to minimize too much of the complexity away because we don't want to create giant magic methods that incorporate too many steps in one because they can be a lot harder for users to debug. So here we have a loop for I in range 5 to put 5 messages on the queue. First we ask ourselves, is it a common scenario to want to put multiple messages on the queue at once? I would argue yes, that is a very common scenario. So this might be some nicer code where we can create a list of messages and pass that in directly. So we can change our put function to take in an arbitrary number of messages at once. And now we've simplified the user's code just a little bit more and made it easier to use. I'm going to skip over naming for a moment and visit hierarchy because it follows on with this concept of minimization. So if we look at our queue client here, you'll notice that we're passing the queue name in for almost every operation. So it might be very tempting to adopt this, where we pass the queue name in the constructor and have that passed in under the covers for each of the operations. This actually changes the concept of what our client is doing. Originally, our client was simply an abstract client of functions. Whereas now, our queue client is representative of a very specific queue. And so now, we've created a disconnect in the mental model. We're creating a queue client that represents a queue, but we haven't necessarily created it yet. We have maybe already deleted it, and yet our queue client represents a queue. So this is where we are wanting to be careful that our API is intuitive as to what this class actually represents. So, should we use an object hierarchy? The Zen of Python recommends that Python prefers flat structures. So, when in doubt, don't introduce an object hierarchy, and we should stick with passing in the queue name for each of our operations. However, a hierarchy can be useful if we are looking at things like scoped permissions, needing to work exclusively with a set of functions for the child or the parent class. And we also need to look at how those two different classes are instantiated. If you do go for an object hierarchy model, be very careful about how a user perceives the relationship between these models and how they navigate between one and the other. So now we've broken our client into two clients. So we have a service client, which is our management level operations to create and delete a queue. And then we have our queue client, which represents the queue itself for putting and receiving messages. How does this change our user code? Again, not much. We're just making client.create now returns an instance of the queue client, and that is used for further operations. Quickly go over some naming. Hints for naming, they're important. They should be consistent within your library. They should be consistent with your documentation, your extended documentation, your articles, your blog posts. They should be consistent with other interfaces that you might have for your service, web portals or applications. And where possible, consistent with other libraries as well. They should be descriptive. We shouldn't be forcing users to go to your documentation to learn what it is they're trying to achieve. So I made a few changes here. Right, moving on. I'm going to skip over asynchronous APIs just for the sake of time. However, long story short, async is still very young in Python, and there has not been a lot of community consensus on how to handle both synchronous and asynchronous APIs alongside each other. Come find me afterwards if this is something you're looking at and you'd like to talk to me about that a little more. Okay, documentation. Some tips for documentation. Add type hints. If you're passing your library around to other users, you may not want to use static type analysis yourself, but we shouldn't stop our customers from doing so. By default, use Sphinx and Autodoc. All of your public API functions should have doc strings, and they should be Sphinx formatted. Don't forget to document your private functions. That will help in distributing your code internally and help others to contribute to your open source code. The README in the repo is the first stop for users who want to learn about your code. So make sure your README has steps for getting set up and has code snippets for all your hero scenarios that they can copy and paste. And then include all the links to your full reference documentation. And there's an example. Okay, so going over our learnings. Test your API with real-world scenarios. Observe users trying to use it, and design your API from an ideal user experience. So start by writing the code that your user has to write and optimize for that so that your user doesn't have to write endless string manipulation, URL manipulation, and then write all the tests that go with that. Start with a minimal API experience that gives them what they need to know right now to get started, and then introduce complexity as on demand. README, once again, your first stop. Make sure it is complete with everything your users need to know to get started. So this is the user code that we started with at the beginning of this presentation. And this is where we ended up. So we've dropped a number of lines of code. It is clearer, more concise, definitely more Pythonic, and it's going to be easier to maintain and easier for other developers to come and take over this code and maintain it going forward. This is the client SDK that we had at the beginning. This is more what it looks like now. So what do you notice here? We ended up writing a lot more code. And this isn't even showing a lot more of the parameter manipulation that we had to do at the beginning of each function. So long story short, writing an API that is convenient for others to use and is nice for others to use, it doesn't just happen by accident. It actually involves a lot more work on our part, but that is work that we want to take away from our users to give them the nicest experience. The ideal API will be invisible. They shouldn't need to think too hard about how to use it. It should naturally fall into place when using other Python libraries. And if we don't take these steps, people are not going to want to use our libraries. They'll either write their own or modify, and if you are publishing open source libraries, they may take your code and edit it to their needs. It costs people time, they have to write more tests, they have to become experts in your code when really they should just be experts in their field. So we want people to use our code, that's why we write it. And the best way to do that is to come up with a really nice Pythonic API that fits naturally in with other Pythonic libraries. And so that's everything I have. Thank you very much for coming. Again, that's me, my email address. Do feel free to contact me with any questions. I'll be down here afterwards as well if you have questions. And once again, I will be posting these slides up on GitHub if it went too fast for you to actually write anything down. Cool, if there's, oh, we have a question. Sure thing. So this is a little bit like the downloads file sample that we went through earlier. So a hero scenario is your most common, your basic scenario. It's the reasons why you wrote the library that you wrote. It's usually very simple, maybe a couple of lines, or ideally, if it is a hero scenario, it should come down to a couple of lines. So it's your core scenarios, and it's why your customers probably downloaded your library in the first place. So if they've gone to your library for a very particular reason, make sure that that reason is well documented, right up there with your README, or if you're not using an open source repo, distributed with your code so people can find it.
One of your recommendations, you suggested avoiding plain verbs, but you ended up, one of your suggestions, you've avoided using plain verbs, but you ended up with methods like put and get.
Thank you.
Would it be better to use put message and get message?
Yes. I'm going to rely on your collective memories here. So yes, we originally adopted the familiar queue-based API, and then we talked about naming and how these names should be descriptive. I would like to have spent a little bit more time on that, but now you make a very good point. I would recommend going through that class and changing them to put message and get message. You'll notice then that there is an additional discrepancy that we follow up with a task done operation. We're now introducing this new concept of a task when we're originally talking about messages. So I would then probably settle on a put message, get message, iterate messages, and message complete or message done. So yes, there is more refinement that could be done with that class in terms of naming.
I might have misunderstood this, but towards the end you said type hints, use the basic, don't use protocols.
No, do use protocols. Okay, so I'm going to back up a little bit here. Okay, so here with our iterate method, you can see my type hit for the return type. I've used a protocol. A user doesn't need to know that the object we're returning is called message iter. It means nothing to them. All they need to know is that how you consume that object is to iterate it. Therefore, by defining the type hint as a protocol, we are giving users more information about the behavior of the object. They don't need to know exactly what the object is called.
One other thing, you used them as the return values, but you didn't seem to be very keen on using them as in the arguments, as far as I could tell. Is that just TBD?
I couldn't fit too much code into my slides, so I cut them down. And that is one reason why people often avoid putting them in, because it can look cluttered in the code. But because we're shipping SDKs that other people are consuming, I do recommend putting them in. It's not about us and our developer experience, it's about our users' code and their developer experience and them being able to run the static analysis tools.
Kia ora. All right. So Christian, so these look like a really good basis for creating a user stories sort of point scoring system. Have you guys been looking at perhaps putting this into something like that you could then push upstream into an IDE so that you just scored on how readable and points for the API that you're developing?
We're currently building it into a set of piloting tools that we distribute internally so that developers simply can't check it in unless it passes our design guidelines. The levels you want to enforce it will vary depending on the guidelines. Every API kind of needs to be looked at independently, and the user base that will be consuming it. What are the common libraries that it will be used to? So simply enforcing all of them outright will not necessarily give you a great API. Cool. I'll still be here afterwards, so do feel free to come down and talk to me. Oh, we've got another one?
You were discussing the difference between using dictionaries and classes earlier. And I'm wondering if data classes might change that dynamic. Like you sort of lean towards dictionaries. I haven't really played with data classes, but would they fit that niche of sort of being somewhere in between?
Yes. I've only looked at them very briefly, and I haven't played with them myself. And I don't think they've been ported back to 2.7. I could be wrong about that. So it does depend on how you're which kind of Python users you're targeting. In our case, for our SDKs, we have to make sure everything goes back to 2.7.
Yeah, I think they're 3.7 only, so that just rules that out right there, yeah.
So that is, yeah, Python compatibility is something else to take into account when adopting new objects, new syntaxes.
I'm just wondering, while you are writing the libraries, which part of the process do you find is the most difficult or has the most of the common issues when you are doing this?
For me, it's very much getting the API design right, which is what I've been sort of spending the last 6 months focusing on, and which has kind of driven this presentation. There have been a number of libraries that I work on. I tend to be involved in the sort of the prototyping stage of publishing a library and actually running the user studies and getting the feedback on them. And as I mentioned, it can be a very humbling experience to iterate over the same API, tweaking just a name here and a function there just to see how users respond to it. It's fun in a kind of laugh till you cry kind of way. Cool. Okay, I won't keep you from lunch any longer. Thank you.